We might be completely alone. When you think about the vast darkness of space, it's hard to ignore the possibility that something, somewhere, may finally be responding. Or that something may have always been there, quietly waiting. Something has changed. For most of human history, we carried the question of life beyond Earth gently. It lived in myths, stories, and imagination. We could look up at the night sky and wonder without consequence, because there was no real way to test the question. The universe felt distant, untouchable. Then we started listening more carefully, and what we heard wasn't comforting. As science advanced, space revealed itself as a hostile place. Beautiful, yes, but unforgiving. Worlds scorched until rock flowed like liquid. Planets frozen so completely that change itself seemed impossible. Stars that flare violently, tearing atmospheres away. Worlds with no air, no water, no long-term stability. When we first discovered planets orbiting other stars, hope surged. For a moment, it felt like confirmation was inevitable. Then reality slowed us down. One by one, these worlds failed. Too hot, too cold. No atmosphere, no water. No energy, no chance. That early optimism faded, replaced by something quieter, more careful, more restrained. And yet the question refused to disappear, because life exists here. And once you really sit with that fact, it becomes impossible to ignore. Earth is not exceptional at first glance. It doesn't orbit a rare star. It isn't especially large or calm. From far away, it looks ordinary. And still, life began. Simple chemistry crossed a threshold. Molecules learned how to copy themselves. Cells formed. Life spread into oceans, onto land, into the air. Eventually, something remarkable happened. The universe became aware of itself. Creatures evolved that could think, that could look outward, that could ask questions about where they came from. That changes how we see everything. Because if life happened once, not through intention, not through design, but through natural processes, then it becomes harder to believe it could never happen again. So scientists reframe the question. Not is there life out there, but something far more careful. Could life survive anywhere else at all? That shift mattered, because real life detection doesn't look like science fiction. It doesn't involve spotting cities or receiving clear messages. Life, especially distant life, is subtle, fragile, easy to misunderstand. We know that better than anyone, so a framework was created, a way to test planets conservatively. Honestly, not to prove life exists, but to rule out where it cannot. 4 tests. They aren't dramatic, they don't promise answers, but they draw boundaries. The first test is temperature. Life depends on chemistry that can move. Reactions must occur. Water cannot remain frozen forever. It cannot instantly boil away. This planet passed that test, not perfectly, not comfortably, but enough. It orbits its star at a distance where liquid water could exist, not everywhere, not all the time, but in regions, during certain moments. And sometimes that's enough. On Earth, life didn't begin in calm conditions. Early Earth was violent. Volcanoes reshaped the surface. Asteroids crashed repeatedly. The atmosphere was toxic. And still, life found places to survive. Small environments, protected spaces, temporary stability. This planet may have those places too. The second test is atmosphere. Without one, a planet is exposed. Radiation pours in. Heat escapes. Water disappears. Chemistry collapses. An atmosphere does more than shield life. It allows a planet to remember, to have seasons, cycles, long-term balance. And this planet has one. Scientists didn't guess. They measured it. As the planet passed in front of its star, some starlight traveled through its atmosphere. That light changed slightly, marked by the gases it encountered. A fingerprint written in shadow. Within it were carbon-based molecules, not proof of life, but proof that chemistry is active, persistent, not empty. The third test is energy. Life is never passive. It builds, repairs, and resists decay. That requires energy, sunlight, heat, chemical gradients. This planet receives energy in a stable way. Its star isn't violently stripping its atmosphere away. Energy arrives in a steady rhythm, day after day, year after year, enough to support cycles, enough to allow complexity to persist. 3 tests passed. Years ago, we might have celebrated, but we've learned to be careful, because the 4th test is different. This is where planets reveal themselves. Life doesn't just survive. It changes its environment. It creates imbalance. It fills atmospheres with gases that shouldn't coexist unless something is constantly producing them. On Earth, life transformed the atmosphere with oxygen, a gas that once caused massive destruction before reshaping the planet entirely. This planet does not show that signature. Its atmosphere appears balanced, calm, quiet. And this is where many people misunderstand the story. Failing the 4th test does not mean the planet is lifeless. It may mean life is young, or rare, or still hidden. On Earth, life existed for billions of years before oxygen became visible from space. For most of our planet's history, it would have looked silent. If we had observed Earth too early, we would have missed everything. That detail matters, because we are not searching for life itself. We are searching for evidence that life has had time to change a world, and time is not guaranteed. So when this planet passed 3 out of 4 tests, scientists didn't rush to conclusions. They slowed down. They challenged their own assumptions. They tried to prove themselves wrong, and the planet remained impossible, balanced on a threshold, capable but unproven, silent. Silence in astronomy is dangerous. Sometimes silence means absence, and sometimes it means restraint. Sometimes it means something is there but not ready to speak. There's an uncomfortable truth here. The closer we get to finding life, the easier it becomes to fool ourselves. The universe is excellent at creating patterns that look meaningful until they aren't. That's why scientists choose patience, because being wrong would damage everything that follows. So they wait. And waiting, in a universe this vast, is an act of discipline. If you enjoy exploring questions like this, the ones that don't rush toward answers but sit with uncertainty, you might want to subscribe. This channel exists to understand the universe slowly, honestly, and without exaggeration. What makes this planet unsettling isn't what it says about aliens. It's what it reveals about life itself. Earth passed all 4 tests, but barely. Asteroids nearly sterilized the planet. Ice ages locked oceans beneath ice for millions of years. Mass extinctions erased most species again and again. Life survived not because conditions were ideal, but because life persists. It adapts, it hides, it waits. So when we see a planet pass 3 out of 4 tests, we're not looking at failure. We're looking at a struggle, a world where chemistry is experimenting, where complexity is close but uncertain. And that leads to a quieter question. If life is a process, not a miracle, how often does that process stall? How many planets reach this point and never move forward? How many worlds come close and stop? Maybe life requires one final condition we don't yet understand. Maybe timing matters more than location. Maybe the universe isn't empty and isn't full, but something far more complex. A spectrum, a gradient of almost worlds. This planet isn't a cradle, it isn't a grave, it's a pause. A question mark written in gas and light. And if one world can get this close, How many others are still out there, silent and unseen, waiting? And how will we know when one finally answers back?